Hello everyone and welcome to Handmade Hero, Short We Code Complete game live on stream. Today I want to take a little bit of a look at the collision detector. We're probably going to do this in like two ways. Last week I did some diagrams on the board just to sort of talk out like how do we want to approach this for what will be our final collision detector that we need one that we can ship now. So this is not like a prototype thing anymore. This is actually, we want one that's going to be reliable. And so what we need to do here is start to go down that route. And what I sort of said was, look, I probably want to do something that's actually not that dissimilar to the one I made for the Witness, because actually I do want something that's going to have the same kind of robustness to it. I don't really like shipping code that's super janky. So I would like to have something that I have some confidence that it's actually been architected well from the standpoint of knowing that things can't get stuck or things like that. So on the screen right now, we have the blue lines are the collision boxes, and currently this is running through a super crappy collision detector that I think we wrote in like somewhere in the first 100 days that really doesn't do anything smart. And so now what we're going to want to do is start replacing that. And so, like I said, what I'd like to do to that, if possible, is I'd like to have the, we can go in here, it's called move entity. So in here, what I'd like to do is I'd like to have a collision routine that in general works in the positive sense rather than the negative sense. So rather than something which looks to see where you can't go and stops you, I'd rather have something that every frame looks for where you can go and puts you there. And the reason that I want that framing is because numerical precision is a very difficult thing to work with. Floating point is not a precise way to do calculations. It's floating point for a reason. It only handles a certain amount of precision for you. That's just how fast computations have to work. They have to be limited in terms of their accuracy or their preciseness. And as a result of that, we don't want, especially in a game scenario where hacking things is important because you want to constantly do random stuff based on arbitrary game design ideas you might have or your designer might have. The last thing you want to do is make it so that you need to maintain extremely rigorous definitions of numerical precision throughout large swaths of the code base, because that will just immediately drag everything down to a crawl, because you really want the ability to just move entities around and slap different velocities onto them, or doing all sorts of things that are just based on making the game feel good to play and game design ideas people are exploring. So you really want that underlying system to not really care about how crappy the inputs were. You want it to take very lousy inputs that might be interpenetrating. They may have been teleported from one frame to the next. They may have very high velocities, very low velocities. They might be really close to each other, really far apart. You want it to just be able to take whatever random crap the game designer or designers randomly did, and you want it to produce the best possible outcome. So you want to try and make a routine that on every frame is trying to help you rather than trying to screw you up, right? If you've seen Glengarry Glen Ross, you know what I'm talking about. If you're going to make something up, make sure it helps. So we're going to take this in two passes. The first pass is going to be to try to change the move entity routine as it exists currently to one that is simply trying the opposite way around. Instead of taking a motion and seeing how far the motion we can go before we hit something, which is it was kind of doing like that sort of a thing, we're going to change it into a routine that just goes, look, I was here, a straight linear extrapolation of the path that the game design asked for would put me here. What's the closest place to that I can put myself, right? And still be in a valid location. So changing it from a let's try to go somewhere and see where we stop to a different thing, which is let's look for valid positions to put myself, and we'll just pick whatever one we can find that's closest to where we're going. But we always will never be doing numerically inaccurate things like doing very small motions or anything like that. We're just going to change it, the way we look at it, to looking through space for some place valid to put people. We're going to do that first. And then the next thing we're going to do is, if we get that working nicely and we're happy enough with it, next week or 2 weeks or however long that takes, then what we want to do is look to see if we can upgrade this routine to being more about simultaneous motion. So we take all the entities, see where they all want to go, and then only resolve problems that actually occur when entities collide with each other. And the reason that we might want to do something like this is because if we keep a system in place like the one we have now, where everybody moves incrementally, so I move entity A, then B, then C, then D, then E, right? Then two entities right next to each other who are both moving in the same direction will not both be able to move sometimes. If the one that's further back tries to move first, it will be disallowed because it can't move into where the other entity was. And then it doesn't matter that that entity happens to then move out of the way on the next frame, right? Now, this is a fairly minor issue because then on every subsequent frame, it will basically be correct. So, but you can produce some little micro stutters and stuff like that. So we might want to try and get rid of that if we can. Not a huge deal because, again, that doesn't really affect robustness. It's just kind of a nice to have. So we'll look at that, but we don't care about that until we get this part right, because this is the part that really can ruin the game. If you have a collision routine that can produce interpenetrating objects or things that get stuck in walls or those sorts of things, like the one that we have currently would totally let you do, that's just a horrible experience for players, and we want to take that out of the equation. There'll be enough bugs in any sufficiently complicated game to worry about without having the collision detector producing crap like that. So that's our goal, is to get rid of that here and to try and move towards something that's trying to help us every frame. It's trying to put things into legal positions instead of generating problems for us every frame, which is potentially moving them into illegal positions, right? So that's what we're going to try. So looking at what we've got here in the move entity routine, you can see that right away we know we already are computing the thing that we actually care about, which is the desired position. If we just turned off the entire loop, right? If we just said, look, we're not going to do anything, this loop is not going to occur, right? So this loop goes away. And instead we just said, okay, the entity's position equals its desired position. That would move everybody to where they want to go with no concern for collision, right? So if we did that, then all entities, and you can see it's like interpenetrating anytime it wants to, right? You can see that, like, if I wanted to go over here, it can move straight through a wall, for example, like that, right? So we know starting out, we have two things. We have where we were and we have where we would be if we did not collide, right? And we can verify that by doing what I just did. So we know this desired position is the correct thing based on whatever the random physical requests are that for acceleration and velocity and crap that the gameplay code wanted to do. So that's a separate piece of code we don't have to care about. We just know that it's going to set those things. We can produce those things here, so we do, right? Now, I suspect, first of all, I'm going to get rid of that because I don't care about that at all. But I would suspect that this should probably move of this routine and be in some requested physics stuff. And we just take the desired point here. So really, what I want this routine to be, and you can see, so this is fine. We can leave it here for now. We don't care. But eventually, what I'd like to do is I'd like to make it so you just pass in desired position. So you just say, look, I'm going to do whatever I'm going to do, gameplay-wise. Maybe that has some physics in it, like acceleration and velocity. Maybe it doesn't. Maybe I just have other ways that I'm going to move things. And when I call move entity, all I really want to know is where should this thing end up on this frame? Where do you actually want it to go? And then we're just going to go from there and say, now let's see if we can make a routine that puts that somewhere, that puts it into a legal position that is close or as close as possible to that desired position, right? Now, if we look in here, we can actually keep some aspects of this routine because, in a sense, we do want to have something like iteration because we probably will need to do a few tries for this. We don't really know exactly what that will look like yet, but we probably will have a for loop here, and we're probably going to try a few subdivisions of things or something like this. So, we might leave that. This stuff is not going to happen anymore. Now, this right here, obviously, we'll replace because this is now n squared. For every entity we move, we have to test against all other entities. And this is not quite n squared. In our particular case, it's actually way, way, way faster than n squared because there are very few entities who actually move. So the reason that this isn't already tanking the frame rate is because although we have to iterate all over, 1,000, 2,000 entities, however many are in the active set at any given time, although we're iterating all of those entities, we don't actually have to test, we don't have to call move entity on most of them. So every call to move entity would iterate over all the entities in the active system to see if they have collision volumes. Terrible waste of time, very inefficient. But the reason it doesn't become n squared and blow up the performance of the system right now already is because move entity is only called on like 6 people. It's like the floating heads and the glove, and that's it. So we do also kind of get a benefit here that actually this routine probably won't have to be that fast in practice because the number of things that actually run through the collision system are going to be actually fairly small. But we probably do want to fix this either way because a simple spatial partition, even a crappy one, would speed it up tremendously because rather than stepping through all the things, you'd only step through a little region of things, and that seems like it would be much better. So a 2-phase pass through would probably be a better idea. So we probably want to replace this with spatial partition either way. But the reason we're not seeing that need yet, the reason we're not actually caring about that, is because move entity is probably only called like 10 times a frame, right? So it just it doesn't go n squared because rather than calling it 2,000 times a frame, we're calling it 10. So inside here, we've got volume stuff for everybody. Now we know that the entity's collision volumes doesn't change. So I'm just going to move that up to the top, not because the compiler won't do that for us. It will hoist, usually, things out of loops. More just so I can see it more clearly. I prefer to see the stuff up at the top that's, my constants for this entity. These are things that, aren't going to be changing here. And then I should probably get rid of this because we're not doing that yet. So I want to hoist those out, and that way I can see, okay, these are the ones that I'm actually using for testing. So these are specific to the entity. Now, if we look here, you can see we're computing a Minkowski diameter. This is for dilation. This is so that we can test the entity as if it's a point, right? And against the things that we're moving. I don't know that we'll actually need to do that in practice because we're going to be sort of changing the way that we are looking at this to be different. So I don't actually know if we really want this per se. This may not really be what we want, but that's okay. Yeah. But we'll see. We'll leave it in for now. So anyway, you can see us here doing some nonsense where we then do some testing that is totally ad hoc. It looks like testing we did for like corners of walls, it looks like. And furthermore, this looks like this was only in 2D. This is when we wrote this. So, I mean, that's probably fine for this game if we really asked ourselves that question. But if you look, it's just like, I mean, why bother? Like, so this was old 2D collision code. I don't think we care about this at all. So I'm just going to go ahead and say that this is going away. This is just lousy, and we don't need it. It's not going to do anything that we care about. And for that matter, neither is any of this stuff. It looks like we've got handle collision and speculative collide. And again, I don't really know that we care about this yet. So when we go to speculative collide, you can see here that it's just sort of, it's just really more of a can this collide. So speculative collide is probably not the right term. We probably just want like a does this collide, and this has nothing to do with collision detection. This is just now us thinking, how do we want this like integrated into the game design part of things? So there's a couple things here. First of all, we want to know whether or not this thing collides from the standpoint of, do we test against it? And then there's probably also one which is, do we stop when we hit it? Because you can imagine us wanting something that does a trigger when two things collide, but that we don't actually stop them. And at the moment, we don't really need that very often. But like... the way to think about it is this. We have an opportunity here to unify more of our systems as well, I guess is what I'm trying to say. So right now, we have some things like, which room are you in? We do that check. It's a separate check. We have things where we test like, are you in a place where the camera should zoom in here, right? I don't know if you remember, but there's stuff in the game from a long time ago that did this sort of stuff, right? So we come up here and we're going to hop... over to like, like the cat, right? So we hop in here and it zooms in, right, to look at the NPC that we're talking to or whatever. So we've got some markup in there that's like where where the puss is. You zoom in on NPCs if these are actual people, not puss, but they same thing. Zoom in, right? And so what we want to be able to do in those cases is we want to be able to know, are you standing in this particular location? Are you in this particular region? Blah, blah, blah. We could then make the collision system just output that information, because since we're already doing all these checks and we're already going to have that system in place, we might as well piggyback on top of it. So, like I said, we probably want a thing here that tells us these collision flags, and probably what we want to do is just make them direct flags we can test. So I don't think we really want things like speculative collide to be happening. That doesn't sound like a very good idea. So probably what we want to do, and we removed the other flag, which is the can collide flag, which I do think is a good idea to remove because I don't think it's what we actually want, but I do think we want some actual flags here. And so what we probably want to do is make these be something like this, where we have an entity flag for whether or not collisions are triggered. So like whether or not we will report. So like reports collisions. And then another one which is like prevents motion through or prevents motion on collision or something like that, right? Event on collision and prevent motion on collision. Now, we don't actually have to do both of these, because we could choose to have the event thing be actually what determines that. So we could say like, oh, events get generated on collisions, and then there's motion that's prevented on collisions, or something like this. And the reason that I'm not necessarily psyched about doing that... sorry, I should say that the other way. I'm not psyched about the idea of when two things collide, I fire some event handler, and the event handler tells me whether or not motion can proceed. Obviously, that's the most flexible thing. And the reason that's the most flexible thing is because it means there's procedural stuff in play that can say, like, oh, yeah, allow this collision or don't, based on who knows what. Like, we check some things about the entity and how many hit points the player has and whether or not they're doing a particular action at that time. And what I think I would like to do is say, no, I don't want to do that. Let's just assume that we're never going to have anything that needs that level of tweakiness to whether things can interpenetrate or not. And the reason for that is I think it will just simplify writing the routine. We'll be able to make a more performant, more streamlined routine if it doesn't have to go out to some other piece of code right in the middle of trying to solve for these collisions to ask whether or not it should allow something to go through something else or not, right? So what I'd rather do is say, look, entity system, unless we actually can point to something eventually in this game design where we're like, we need to have this be completely dynamic, and there's no way we can set flags ahead of time that would say it. Because remember, you can always clear and set this flag, so you can always have things that like turn on prevent motion and turn off prevent motion. That's fine. It's only just like, do you need to actually take two things and compare them in some complicated way to determine whether motion can pass? I mean, we can even have things like different prevent motion flags that, you know, if you could just set entities up so that they have a mask, that'd work too. So I'm just going to assume that no matter what we want in the game design, we can make something like that. But in general, there's always a way to know without calling out to a gameplay routine whether or not two things can coincide or not in space. So that, I just want to make that statement up front. And so what we have here is two flags that control what the collision detector's behavior is going to be. One of them says whether or not you want to be notified when two things are overlapping. And the event on collision thing will just be if either of the two things has that flag, right? So if either of the two things has that flag, an event will go into some log somewhere for processing gameplay purposes or however we want to do it, doesn't matter. That system will just end up getting notified out of the collision system at that point. If we have prevent motion on collision set, then anytime there's a collision of that form, whether there is an event generated or not, it will prevent motion through there. So those are the two things that I wanted to have there, and we're not going to call things like speculative collide. That's not going to happen, right? Okay. So we don't care about any of this. I don't care about any of this stuff or this stuff, like literally none of this stuff, right? So more or less all we're going to do here is we're going to want to have this handle collision call at some point, but what I'm going to try and say, like I said before, is I want to try and have that on the outside. So we're in here in the for loop situation or whatever. I want to make handle collision in so much as I can be something that is called after the fact. So basically, like, we do all the work, we will stack up like who is going to get notified, and those are just going to go into some like ring of things to get processed later or something like that, right? Now, fortunately for us, we don't even have to do that right now. What you can see here is we didn't have anything in that routine. And similarly, like can overlap, doesn't look like it was used either. So hopefully we can just get rid of most of this stuff. So in can overlap, which we now have a Boolean for, I could keep that routine around. I'm not sure if I actually want to or not. We'll see in a second whether I do. But if I just do this and get rid of can overlap, it should just be removed. No, yeah. So maybe I want to keep that routine around and it just does that flag test I just said, but maybe I want the flag test welded directly into here. So we'll see whether I want to pull it out later. I'll just assume for now that I don't. Okay. So taking a look at what's going to happen here, now what we need to do is say, all right, what's our strategy for determining whether or not we hit things, and if we hit things, determining whether or not we need to actually stop the motion one way or the other, right? So let's do trying to think of how I want to do this here. So let's do something, because I think what I'd like to do is again do something where I kind of subdivide space a little bit and search. I don't want a line, because a line doesn't allow gliding along walls, and it also wouldn't help us displace ourselves out of interpenetration. So we want a search over some space, right? And we know some things about the size of the delta. So whatever this is, I don't know. It's player delta is a dumb word because this is not the player. So this is really just delta p here, right? It's not like have anything to do with a player, because this is moving any entity, not just the player. So when I take a look at the delta p in this case, can we also just take a minute to reflect on the fact that that purple color is absolutely horrid. We don't know for a fact that Ryan Fleury is colorblind, but it would seem that he may, in fact, be colorblind if that was the default color. Let me take a look inside here at the themes. This is the themes. What is that color? Is it token highlight? You know what I'm saying? Like that is just a horrible purple. 2F2F37. No, that would be like a blue, right? Am I wrong about that? So that's actually this underline here. So it's like a different. It's like a token highlight for other places that aren't there, or something. Does anyone know what that is offhand? Because it's really aggressive, that purple. A little bit too aggressive. You know what I'm saying to you? Anyone know what that is? Anybody? Purple means it couldn't find the variable. Okay, so basically there's some variable we're not setting. You know what I'm saying? Oh, Terius Python. But is there a way to just set the color? Like, can I just set the color? Is there some setting for the color? Minor highlight. Okay, minor highlight. Yeah, that's just not set. So let's just set that, and then we can just have it, right? It's not an issue if we just set it to a color that doesn't kill it, that isn't horrid, right? Flurry color token minor highlight and minorly. We don't know who's responsible. Terius Python. Terius Python says that's the case. So if I just do this, do we now believe that this will be fine? That everything will be fine? Move entity. Let's take a look. Oh yeah! Thank you, Terius Python, for saving the day. Cause that was pretty garish, you know. If you don't mind me saying so. Just a garish purple. So yeah. We could make that a little brighter too if people are having trouble seeing it, but I don't know how much I care. Like, I don't usually need to see that well. But, you know, at least now it's kind of like, okay, not too bad. All right. So at this point, like I said, what I need is a way to go through and test space in a way that lets me figure out where I could put this thing that's close to the place it actually wants to go. And I think the way I'd like to do that, again, is just to break down space into some pieces. And so maybe what I'll do is just kind of look at it like a like kind of a subdivided grid, probably. So what I may do is something like... Oops. Did that just... Yeah, it did. Deleted my stuff. So maybe what I'll do is something like this. I'll do like subdivision levels here. Or something like this. And for each subdivision level, I will look through some number of... I may even want to stack. So for each, I want some way of like subdividing space. And I could do this by just doing a blanket grid. In fact, you know what? Let's do it with a blanket grid first. So just a fixed size grid. And it'll be kind of crappy, right? But let's do it with a fixed size grid first, and then we'll add subdivision after, because that'll just make the problem a little bit simpler. You know what I'm saying to you? So let's do it with a few for loops here, where we just take and we do like a dimension here where we say, all right, we're just going to look through like a 4x4x4 or something. And we're going to see which of these cells is available to place the entity in. Where is the best place we could place it in this series of cells, right? So starting from the location and moving outward in a radius that's roughly the size that you want to move, we're going to see to what extent we can like break the thing down into pieces, and we'll see what happens, right? And what I might do is say, look, this thing is going to potentially have to run multiple times as well. So what we may do is make like kind of a little bit of a kernel here. That's maybe something like move entity small, or move entity locally. Like something that's just a very small perturbation. And then this code here is going to be something that happens only on like a small movement. And so here what we may do is say, well, if this move is too large, so if the actual like the length of the motion is too large for what we're doing, we're going to break it up into pieces. You know what I'm saying? So we'll just say, and this is why I said I didn't care about that to-do from before. We had a to-do that was like cap the maximum velocity. I don't think we want to. I want to just take whatever velocity you ask us to and split, right? Okay. So if we're going to take the velocity and split, I need like some total motion. And again, you know what to do? Subdivide motion into max size steps. Again, I won't bother with that yet. I'm just going to call move entity locally first, and we'll do that subdivision there as a separate step as well. So off we go, and what we want to do here is call this function with the entity who's moving and the desired position of the entity, so where you're actually trying to put it. And I might even say like something like that. So we want like a v3 from and a v3 to. So this is where we're coming from. This is where we're going to. This is guaranteed to work as long as these are fairly small motions. And then we need to pass the region and the entity because we need to know the entity's collision volume. We could, if we want to, just pass the collision volume. I'm going to pass the entity for now. We'll think about how we want to do that later. So we're going to do this, which gives us information about that motion. We're not going to do the subdivision yet. I might want to make this a little easier on myself for iterating. We've never made a voxel iterator here, so maybe that's not a great idea. But you know, the index to the voxel, we would basically do something like, you know, while voxel I z is less than the dim z, you know, off you go. And then at the end, you do like a voxel I x plus, and you say if voxel I is greater than or equal to the voxel dim. This is just a standard way to do the iteration, right? So if it's greater than or equal to the voxel dim, then you do your other increment. And in here, I would also do voxel I x equals 0. And then the last one, voxel I z, y, greater than or equal to voxel dim, y, voxel I y, 0, plus plus voxel I z. So that's a simple way to just do one for loop. Well, it's not a for loop, but you get the idea. One loop that is going to do all of the squares of a voxel, right? All of the indices of a voxel. And then in each one of these, I'm just going to go ahead and test. So this allows us to do our sort of our breakup, right? Our discretization of the space. And in each one of these, I then need to put in like the cell dim. So here's the cell dim. This is going to be how big that voxel is. And again, I think the way that I want to do this, like I said, is I want to break out the space in a way that ensures that I'm looking at the place that I was at, the place that I'm going to, and some reasonable apron around it. Again, the reason for that is this is not trying to be an accurate physical simulation at all, because this is a game. We do not care fundamentally about the accuracy of the physical simulation. What we care about is that we recover from screw-ups gracefully. So if the game design code that like does a bunch of random crap ends up sticking two objects inside each other, right, or like one inside another, we want to be doing searches outside of that space to try and ensure that like we'll get those things will separate at some point, right? So what we want to do is we want to try and look for places we can put things so that they will split in those cases. Now, the only thing that's a little bit dicey here is you may want to do something like you check to see whether or not you're currently interpenetrating at the start of a frame, and if you are, you search over a relatively large area to try to get yourself out of that location. I don't know to what extent we want to do that. It probably depends on just how bad we expect the gameplay code to be doing things like that. My hope is the answer is not very, right? So yeah, so I think that's, I don't know. This part is not that important because we can always pick larger ones later. But what I want to do here is basically say, okay, we've got from P and to P. And those are going to be like the corners of this voxel. And then we're going to extend it by an apron, right? So we want to do like a total voxel dim. And the total voxel dim is going to be like, and in fact, I guess we could do, we have a rectangle 3, rect min max, right? So voxel bounds maybe is the right way to do it. So we do voxel bounds, and we say we want to go from the from P to the to P, right? And the problem with this is we want the min and the max. Do we have a min and a max for vectors? Like, we want this, right? You know what I'm saying to you? Looks like that works. So basically, we want to take the entire span of the move, like whatever that is. The heck is this? Oh, this is like this is like the C tray. We don't need that. I don't know why that's up there. So this is the total bounds of the move, and then what I want to do is I want to do like an add radius 2. And so I want to make sure that however big that is, we also look at some region, or some small region around it that's like the epsilon. And I can call this the apron size or something. And again, I don't really know how big that should be. That's a really tough call because I don't know like how much space we want to look at. But it's going to be something, right? And we're going to want to tweak that. And hopefully we can maybe draw some of this stuff so we can see it and make some more informed decisions about it. We know that 1.0 in this game is a fairly large distance, right? That's like the distance from like one square to another on the hopping or whatever. It's like, you know, about 1 or something like that. So we know that like this would be like 1/100th of that distance, which would be pretty tiny. And so, like I said, I don't know what we want this apron size to be. It's tough to say, but it'd be something in this range. You know, maybe it's that, maybe it's this. I don't know. We can play with it. So from there, we would say, okay, the voxel dim is something. We know that the voxel bounds divided by the voxel dim would be the actual thing, the actual dimensions of each individual cell. And I don't know why this is that, I suppose. Another way to write this would probably be this. And why am I getting Grumpus? Why is it Grumpus here? All right. So here we have the voxel bounds and the voxel dim. We want to do a divide. We don't have a divide for vectors. For no real reason. We probably should. Because sometimes you want to divide, right? And so I'm not sure, I'm not sure why we wouldn't. I guess this is actually... Do we have a Hadamard divide? So we call that Hadamard. I probably should have just used multiply. It used to be that this was rare to see a Hadamard product written as operator times. But now it's not because shaders do it. And so now everyone's used to just writing times for this. So, you know, I think I may just cave on that and say, look, man, Hadamard is just times now. Because doesn't really make a lot of sense. Alright, so anyway, let's suppose this is operator slash from Guns N' Roses, and then we'll just, do the divide here. And really, this should probably be operator times. That should probably be that. And, we should probably just change that, right? So in here where we had these, we should probably change those to something else. And you can see, like, just trying to look at how many we have. It's not even that many, So I do think maybe we do that. Let's maybe do that as well. Just get rid of those because I don't think it makes a lot of sense, honestly, anymore to bother with that. Like this is in game parlance nowadays, operator star is pretty much what it is, and so it's you might as well get used to it because that's what it's going to be in basically everything you do. So cell dim times whatever this is here, right? Is all that's going to be. Same here. Oop. There's that super aggressive token killing for some reason. Does anyone know that answer, Tarius Python? Do you know how to get it to like actually just delete a token when you do that rather than deleting 2 tokens for some reason? Right? Like it for some reason deletes way more than a token, even though I thought I bound that to delete token, but maybe not. I don't know. We'll have to look. Maybe that's in the yeah. I don't know. Something's weird. I'm not sure like what that is, but it's not great. So anyway, looking at this again, all looks pretty straightforward. Why is that say Hadamard when there's no Hadamard there? Is that is that that's a bit weird. I don't want to know what was going on there. We won't ask these questions. All right, there we go. And oops. Yeah, I would really love to get that fixed. It's one of the only remaining things that super bothers me in this editor right now, is that weird, like, super aggressive, like, when you hit delete, it deletes, like, everything. And I don't know why it does that, because I thought I bound it to just the token delete. Like, if you look at the bindings file, so this is what they're bound to, which is obviously not right, or, you know, maybe it is. Maybe it's the only thing that there is. But is there, like, a thing that's better? Like, something that would not do that, that would just delete 1 token at a time? Maybe it's white space or token boundary, or just backspace token boundary? Anyone? Any guesses? 4coder experts out there? There's that, and there's also the other fact was that, like, the weird, like, when I'm opening a file, it deletes the whole thing. Like, only deleting just characters at a time in that thing up there. Those are the 2 things I would be very interested to know if anyone knows the answer. All right, so doing some stuff, getting rid of the Hadamard thing, because I think it's pretty standard now these days that times is Hadamard product. That's just what happened. I don't know why. You know, they could have picked dot product. They could have picked cross product. They could have picked Hadamard product. The powers that be picked Hadamard product. So at this point, I don't think there's much point in dithering about it. It's really weird too. It's like not even symmetric, right? Like if you're here and you hit delete, it deletes the parentheses and the Hadamard. If you're here and you hit delete, it just deletes the Hadamard. So like it's really hard to even wrap your brain around because it's doing like all the alphanumerics and stopping when it hits white space or a symbol, which is not something that your brain does like it's not an operation your brain would normally think to do. You know what I mean? Or that it wants to do, like, or naturally, you know, I feel like. So it's kind of like always confusing. Victor C- says that there are some things I can try. So we're going to try them because the way it is right now I don't like. So it can't be worse. Backspace token boundary. Is it actually D-R-Y or is it D-A-R-Y? Is it actually spelled wrong? I guess we'll find out in a second. Part delete token boundary. Okay. So if we do that and then do forEd, let's take a look at what happens. Ah, yes. Much better. Thank you, Ryan. And thank you, Victor C-. So yeah, only other question is there a way to stop it from doing that? Like when you do this, is there a way to make it only just do a character at a time? Does anyone know? That'd be another nice thing to have. So we're getting down to things where there's not too much problems at the moment. There's the indentation is broken, which is just a bug. I don't know how long it's been in there. A long time. So that's unfortunate, but hopefully that's just a bug that will just hopefully get fixed at some point. All right. So that's all good, and this just needs to be like a v3-ified version. So voxel bounds, so we can divide those two, right? And that will give us the dimensions of each individual cell, which is good. So we have those. And then we should be able to construct the positions from there. Oh, cool. More infos. Someone says that in the config file, if I set lister whole word backspace. Yes. Wait, but that's set to false. Isn't that what? Lister whole word backspace when modified is already set to false is the only thing. Which, does that mean it just doesn't work anymore? Maybe? Or do we set it to true for some reason? Which... Try true. Now that's confusing, but we'll give it a shot. Yep, that was it. Wow. Okay, so that may just be a poorly labeled parameter, I guess. But hey, man, I don't care as long as I gets what I wanted. I don't care. Okay, so now we're compiling again with the Hadamard product. Let me just test to make sure I didn't break anything with the Hadamard product. So that's all good. It looks like everything's fine. So let's go back to trying to help these little fellows move. How much time we got here? We have like 1 hour, probably. I don't really know. So if I go back to move entity locally and we take a look here, you can see that I've got my voxel. I'm stepping through, and at each point in the voxel stepping, what I want to do is determine whether or not I could stand in this place on the voxel. And what I might do is just look to see what I might do is just look to see, like, what the corners of the voxel are that I can stand on. You know what I'm saying? And I'm trying to think if I'm actually overcomplicating this by actually bothering to step through a voxel at all. Because what I was thinking is, can I just start at the place I was trying to put myself, so the 2P? Can I just look around there to see if I can place the player anywhere? And if I can't, I just move outward from there. And I'm just really not sure about that. So here's what we're gonna do for starters, just cause I don't really want to think about it too much until I actually have something working and I can play with it. So what I'm going to do first is I'm just going to say, okay, there's a voxel dim here, and it's maybe more like this. And I just want a voxel occupancy, like a thing that basically says, like, could you stand here or not, right? So there's like a vacant, you know what I mean? And I want that to literally be whatever to be voxel addressable. So we just have a little thing that's going to say where everything is or isn't, right? So when we come through here, I need to first say, like, hey, this better not be the one I'm actually on. So, like, test entity had better not be equal to entity, right? But assuming that they're not, then we'll go through here and take a look at them. You know what I'm saying? Okay. And then what I want to do is for each of these, we're going to take a look and we're just going to test the place in the voxel that we are. So wherever the voxel location is that we're actually at, we're just going to test that voxel. And I want to make this an iterator. So, like, I want a voxel iterator here, actually. And so I want to make this thing be... something like that, probably, so that I can roll this in. So there's a thing that looks like iterate voxel, this kind of thing. You know what I'm talking about? So all I want to do is exactly this. So I'm going to grab the while loop condition and I'm going to make that be the thing I return. And I'm going to return this condition as whether or not we're still iterating. For advance, it's literally just this, the code we already wrote, right? And then for starting, and this is all just, you know, oops. And all of this is just going to be whether it's the I or the dim, right? So here we've got, you know, the I is the thing that's in each of the left sides, and the dim is the thing that's in each of the right sides. Now, we don't actually need this thing to record the dimension because it's duplicative, so you could choose to just not have that, right? And to do that, we would just say something like this, which seems plausible to me, so that now it's just that. And that seems fine. You could even go one further and say we don't even have a type for it. It's just iterate voxel and it returns a v3s, right? Which would be kind of nice. But who knows? Like, I don't know. Maybe we want this to be fancier. So for now, I'm just going to do it this way and be fancy, but we don't really need that. So I don't know if we'll, you know, I don't know if maybe we'll simplify it later on. Okay, so supposing we do this, the voxel, this part here is just literally just dim and 0. We can have an offset, but I'm not going to have one at the moment. So here we're just going to say iterate voxel and you pass in the dimension. It remembers the dimension and sets the initial thing to 0, like this. And off we go. So that's the voxel iterator, and in here we would now do a for loop, voxel iterator vox I equals, or voxiter or something, iterate voxel. It's going to take the voxel dim, and off we go. Now, also, those are all S's, right? Yeah. So we pass that in there, and then we just have an is valid, voxiter, and an advance, or next in order, maybe. Maybe it should be. And so this is just, we'll march through the voxel in order and do what we wanted to do. So I think that's all we need. And now we're iterating over all the pieces of the voxel. And we can then say that as we loop through here, what we could do is say that the thing is, and you know what? Maybe we'll do occupied instead. So everything defaults to not occupied. If we find somebody who is occupying it in here, we just set that, right? So if someone's occupying it, we would set voxiter IZ. Doesn't really matter which way we do this, but, you know, X, Y, and Z. So we want the occupied to be set to true, and we can also stop because then we've found out that you can't stand there, right? So I want to do something like that, where we test, and here is where we would do the test. So like if, you know, the overlap test on this piece of the voxel corner, off we would go. Finally, we will step through the voxel a second time. So just a 2-pass algorithm where now we will look to see. And what I want to do here is step through the voxel at one less dimension. So what I want to do is I want to step through the voxel dim minus 1, right? So I'm just going to now, so before I was looking through like voxel positions, right? And now I want to, so like one way to think about it is I wanted to step over vertices here, and now I'm stepping over cells here. So I want there to be one vertex on like the other side of what I'm looking at, right? And so then what I can do is I can just see is this voxel completely unoccupied? And if it is, I'll just take the closest point inside it and treat that as a new valid position, and if not, I won't, right? And that's all I was going to do. Someone on the chat asked, can the amount of time the entering second hour notice be displayed, can it be adjusted? Yeah. It can be adjusted in C-Tray, right? I think. To be honest, I don't really remember anything about this program when I wrote it. But it does have a thing in there that determines whether or not it's going to show that. So it looks like it displays it for 1 minute. So if you wanted to change, you know, if you were building this program yourself and you wanted to change it, this else statement would be what you would change, right? And arguably, if you wanted to start doing cool stuff here, you could just make an array of ranges. So rather than doing in minute, you could do something like, is it between here and here? And then you just make like a range and, you know, set whatever you want. So you can fuss with that if you want to. You can also just change this routine. If you want everything to display longer, you can just change file time minute to 2 times file time minute or 10 times file time minute or whatever, however many minutes you want to display for, you could do. So there's that. But yeah. Anyway, so back to our story. Yeah. So in here, what I want to do is just say, look, if all of these are, so if I were to just like take all of the occupieds, and just do a big munge. So like if not, like so, and I said like vox iter I z bloop bloop. So if we were to just check like all of these booleans, and again, there's going to be like a better way to do this than we're doing it. But again, I'm just sketching out the routine, and I'm not thinking about optimization. God, I wish the indentation in forcoder would be fixed. I do not know. It used to work, it broke, and it seems to not be like going to be fixed for some reason, which is weird. Because how that doesn't drive people crazy, I have no idea. So looking in here, like if we look at what's happening, we could just like smush these together. There's going to be 8 of them, right? Because it's the vertices of a cube. Well, it's not necessarily a cube. It's a vertices of an axis aligned bounding box, effectively. But we would gather up a bunch of booleans and smush them all together. And we would then know, like, look, if there's nobody occupying this whole set, so if nobody's occupying anything in here, right, then I'm free to place the player at the closest point in this region. And this function is what would do that, right? So if we said, what's the closest point to the thing in this box? Well, we can make the box, and we can get the closest point, which, as you can see, is a trivial operation, right? You're just min-maxing it, right? And off we go. You don't have virtual white space enabled for forcoder. Is that the Yeah, I couldn't really get virtual white space to work right when I tried, so I just gave up on it. Like, it had trouble with like comments, and it had trouble, I don't know, it had trouble with a lot of things, so I just like forget it. But so I'm just using the regular, but I would like indentation to work properly, right? If that makes sense. So all I want to do is say get closest point in box to this. So I want to put it in the 2p place. So I want to get the closest point in this cell, this voxel region, and that's going to be my test point. And then I just want to do like, look, if the, do I have distance squared? Yeah. Or no, I don't. All right. So if the distance between the test point and I guess what I should probably do here is just have a best distance squared. So now I think about it, I'll probably just do this like test dist squared. So if I take the squared length from the test point to where I'm trying to go, which is the 2p, that's the, like, I'm going to say how far is it from the point that I'm actually trying to get to. If my best distance squared so far is greater than that, then I want the new one. So I want my best p to be test p. You've seen me do this, type this code 1,000 times. So we'll just keep that one as our new best point. So here we're going to have our best distance squared. Our best distance squared from the test point is going to be our current point, probably, I would say, right? Well, that'd be only if it was in there. So no, I'm just going to say this is F32 max for now. And then I'm going to say our best P is where we're standing, right? And so, and maybe we should change this. Maybe we should be like, if you can't find anywhere to put the thing, then the player just goes wherever they want, right? You can see why that might be safer. Like, if the player just gets stuck in some crazy out-of-bounds scenario, just let them be in God mode so they can get themselves the heck out. Plus, speedrunners, right? This is the stuff they live for. You know what I'm saying? So yeah, so maybe we default to saying entities can do the move they were trying to do. Of course, it doesn't really help them. Well, it would help for the glove. I'm thinking like the player moves on the squares. They don't run this through this routine, but you get the idea. So speedrunners, you're welcome. So this will be like, if we can't find any legal place to put you in the vicinity, we just let you do the move. And that way you can't get something stuck permanently. It'll be able to get out somehow, right? Okay, so we go through here, we test, we see if we find a place. If we do, then we use that. And then at the end, we just say, all right, so the result here is that the entities gets placed at the best location that we can find, and you continue onward, right? So very straightforward. This is complaining. I don't know what it's complaining about. To be completely honest with you, so I don't know what's going on there. Oh, that is wrong. So I'm really in the habit of typing V3S because of Star Code Galaxy. There are no floating point things in the beginner course. So I'm very used to it's like my brain is not thinking of V3s at all. So we just need to produce this cell, and that's not particularly difficult, obviously, because we know that that's just going to be whatever our voxel bounds are plus an offset, right? So the cell in this case is just going to be a rectangle 3, which is a rect min dim probably, where we take the min, we offset by the vox iter I, right? And times the cell dim. And that's just going to place us in the right place. And then we have the cell dim itself as the dimension. So the cell should be pretty easy to get. And off we would go. This is supposed to be a minus. Don't ask me why it wasn't. And now iterate voxel seems to be complaining. What's it complaining about? We have a voxel dim here, which is a V3S, and we're subtracting 111 from it. I'm not sure why that would be complaining. It returns a voxel iter, so that's a little bit weird. What's the actual warning? Oh. What? Is that just because of this? Okay. So the fact that there was a placeholder in there was causing the compiler to not realize that this had been closed at that time. So it was thinking, I was like, voxiter only exists inside this for loop scope. It's definitely not being shadowed. But okay. So if we basically say that, look, we're going to run this in a not really real way, but I want to test it in waves because we've got a bunch of complexity here. This is going to test all the voxel cells, and it's going to put you in the closest point in a particular cell to where you were trying to go if that cell was empty. What I want to do is just leave all the cells empty right now, so it should, in general, we want to get this working first, because if this doesn't work, we already have a bug before we ever do any collision detection, right? We're just trying to say, like, you should be able to move inside the cell that you're in, and whatever. And so you can now see, like, okay, everyone's moving freely, which is what we would expect. They can penetrate directly through things. They don't have to stop, which is exactly what we'd expect because we're not testing anything. So that means this is probably working okay. We don't know for sure, but at least I'm just, bringing it up in waves so that we kind of have a reasonable idea of what's going on. One step at a time. So now all we have to do is test these corners, so we can, determine whether or not something's in there or not. And so this should be pretty straightforward. It's just a point test, so it's just a point in box test. We are going to grow this Minkowski diameter here and see, like, can the player's cube, or can the collision cube stand it? Now, this is going to get more complicated, and the reason that this is going to get more complicated is that in the future, I think we probably want cylinders, so we're going to have more of a cylinder-cylinder collision test here, or, other things like that. So we're going to want this to be more flexible than it is, because we're going to want at least a few different permutations. Cylinder, we're probably going to want cylinder-cylinder, cylinder-box, and box-box. Right? So that's presumably what we're going to want there. Okay, so here's us doing stuff for no reason, is what we're actually doing. You know what? I might take a quick break, actually, because we've been going a while here. We've been going... God, how long have we been going? I might get some more water. Well, this is actually lemonade, full disclosure. I'm going to take a quick break. I'll be right back. water has been refilled. Because we started 2.5 hours ago. I gotta talk more quietly, so I don't get my voice too going. All right. Okay. Hopefully everyone enjoyed that brief, peppy song. All right. So this all seems fine, and so all we really need to do now is to just do an overlap test here, where we take a look at that collision volume, and we make sure we know what's going on here. So you can see here we do a relative like entity P, volume P, test volume P nonsense. This is simpler than we're making it out to be, I think, probably. All we really need to do is go if the person was standing here, and so on. So if we look at the collision volumes are presumably, I don't even remember. Not that. There's a collision volume thing in here somewhere. There it is. So these are just offsets from the position of the entity. So in theory, I think all we really need to do is say, look, we know where this rectangle would be. So the test rectangle is just going to be whatever the test entity's position is, plus like as an offset, right? Of the test entity's position and the test entity's collision volume produces the rectangle in question. The rectangle for the Vox, like where the mover would be, so like mover rect, I don't know what we want to call that, is just taking whatever the base voxel position is, so whatever this position is on the voxel, and offsetting the collision volume of that. Now, I don't remember much about the offset function, but it looks like, yeah, so you just take, so it's the volume first and then the position, so it's really that way around. And none of this matters. That's all gone. So then we just do like intersection. We just use our intersection call to see whether or not the rectangles intersect here. So presumably we can just call that on these two, so the mover rect and the test rect. And presumably we can just go from there. So all we need now is to know what is the base voxel position. And again, I think that's pretty much straightforward. It's really just whatever the it's this right here that we were whatever we were going to use as the position from before, right? So I'm pretty sure that all we have to do is take the entity's collision volume and offset it there. And now what we've done is like point sampled this collision function to see which vertices of the voxel you could place the player on or place the mover on. And then we just use whatever the largest, whatever the closest open voxel is, and we place you in there, right? And that's all we're doing. And so that should maybe start to actually work now, but I don't actually know. It doesn't look like, I should make sure we're actually setting this properly. So recommended is seldom closest point in box. If not occupied, this does offset rectangles intersect, then it sets it to occupied. Okay, so this should now be working, although it doesn't look like it was. So now we have to actually start debugging it. Right, because I can still go straight through that wall, right, which I should not be able to do. Although actually, I guess. Yeah, so we're actually doing this, right? Like everything is actually happening. We're calling move entity locally. We're doing in here, we're saying, place these two things. Yeah. All right. So why aren't we working? We have voxel bounds min plus voxel radius, so that's the corner of the voxel. That would be the point where the player would be standing. So that seems right. We're placing the collision volume there. This is placing the collision volume wherever this entity actually is, right? Which is what we would expect. So yeah, I can't say I see why that's not working. What I would like to do, so I'd like to step through here so I can watch. The only problem is, like, I'm not sure there's much I can really, like, we kind of need to set up a case here. Because this is just going to be, if we try to step through it in the real game, I think it's going to be too complicated, right? So there's two different things I'm thinking. One is I could draw this, which I think I probably want to do. But the other is I kind of want this to be something I can test. I just need a case I can step through where I kind of have some idea of what should be happening so I can watch carefully what actually goes on. Because, yeah, it sure seems... So let me see, I'm curious. Is this just always failing out or something too would be the other thing. So if I prevent motion in the case, so speedrunners, you're not welcome, does that stop everyone from moving? Yes. So basically what's happening here is we're never actually getting an unoccupied one of these, it looks like, right? Appears to be the problem. So if that's the case, maybe I can just step through it directly. If it's always failing, I should be able to just look and see I should be able to just look and see at that point what's going on, because it should be relatively clear what's going on at that point. So maybe I just do that. And we just see what we can see. Oops. Entity. And let's take a look. Should be like in here somewhere, right? Or does it not? I guess it's in the sim region code. I don't know where we actually put this thing. Here, probably. Yeah. So let's just take a look at what this looks like. I should probably be in debug mode because we don't really want to have to deal with all the nonsense. Can't inspect any variables in debug mode, because how would you ever inspect variables? That's just an unsolved problem in computer science. It's not like the CPU ever computes those variables or anything. So if we go ahead and look here to see what is the stuff that's happening, so from P and to P, so this is an actual move, right? Which is good. That's what we want. And if we look at the apron size here and set up these bounds, let's take a look at what the bounds ends up being. So that seems fine. Like, doesn't seem totally ridiculous to me. So the cell dimension, what is it? Cell dimension quite small, which is what we want. We're trying to do small stuff here. So let's see what Voxeter says. Voxeter is exactly what we would expect. We are going to iterate through these things here and see, we're definitely not getting, like, it's not like everything is suddenly intersecting. Oh, duh. Forgot. Soft Bean! Yeah. How you doing, Bean? Do you want to say hi? Say hi. Say hi to the camera. No? Okay. Don't say hi to the camera then. What are you doing, puss? I just was gonna tell people that there was a bug in here. Did you want to tell them? Did you want to tell them about the bug? You can tell them. You can tell them about the bug. You know? Okay. Here, tell them about the bug. 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 You know what it is, right? Do you know what it is? You already know what the bug is? Here, come up. You can come up. I know you want to hang out on my shoulder. Come on. Tell them what the bug is. Don't keep them in suspense. Don't keep them in suspense, Bean. You already know what the bug is, don't you? You're one of the best programming cats I know. You always know what the bug is. You don't always tell me because all you do is muse sometimes. But you know what it is. I bet you do. That's right. Here you go. Tell them what the bug is. Can you tell them what the bug is? What do you think? You want to give them a hint? All right. That's okay. I know. Everyone needs to learn on their own. If you just told everyone what the bug was all the time, they would never learn, so that's fine. I understand your pedagogical methods. All right. You want to sit in my lap? What do you want to do? You can't be on my shoulder for the entire time because I can't type, but you can sit on my lap if you want to. So that will work. If you want to give it a shot, go right ahead. Okay, so what I was going to say is I forgot. We literally said this at the outset. So the problem here is that we have things that are not actually motion preventing elements, right? So what we want to do here is say, look, we don't want you to actually prevent motion or collide if the thing that you're colliding with doesn't have a flag set that says it stops motion, right? So we gotta test those flags in here. Otherwise, you're always going to be hitting something. Like you'll always be hitting at least the room boundary marker, right? And so that's just something we have to deal with. So, what are you doing? What are you doing? What are you doing? What's going on? Oh, come on, puss. Come on. Okay. All right. You just want to cuddle. You don't want to do any programming. You just want to hang out. Did you just eat your... Oh, you know what? You just ate your dinner, your lunch, didn't you? Your automated feeder go off? You just had your dry food, your lunch dry food? Is that what happened? Yeah? That's a good girl. That's a good girl. That's a good girl. All right. Oh, you're going to eat my hair now. Okay. Well, I don't know that we really need you to do that, though. So maybe, why don't you just sit there and I can type in the flags code? How about that? What do you think? Does that sound good? At all? Okay, so yeah, I don't know how we want to do this exactly because most things that have a collision to volume probably want to prevent motion, and it's probably the rarer case that you have a collision volume that doesn't want to prevent motion. So I don't know if we actually want to do the flags the way round that we did them. We probably want to do it the other way so that we specify things that that don't, or something like that. You know what I'm saying? So if we look at the flags for entities, I'm just guessing that that's what we would want to do. So maybe like, maybe this should really be more like allows motion on collision. That's a good Puss. Okay, Puss has settled down now. She's sitting on my arm, which is not the most comfortable thing for me, but it does allow me to type, which is really the important part. So what we'll do maybe is set allows motion on collision for things like the room. So if we look for where we create the room by Tommy Wiseau, we can set for those types of entities things that say, look, you can just walk through these, right? That don't actually stop you. Well, not walk through them, but you can move smooth movers through them. Obviously, walking is done by the actual transactional motion system, so it doesn't care about these settings. But when we set the thing like the room boundary stuff, that would actually do it. So in here where we do add entity, right here, you can see this, right? What we would want to do is say like cam room flags or equals entity flags allow motion on collision, so that we know that this thing won't actually stop other stuff from going. And we do have at least one other one of those, so we might as well set that one now as well, which is when we create things like a conversation section. So like when you go somewhere that you're going to like, someone hops onto it, and oh gosh, okay, you all set there, Puss? What are you doing? Puss is wrecking havoc. So conversation stuff, when we add one of those also would, like, those would not stop you either. Like the glove should be able to move through those cleanly and so on. All right, so let's start with those, and let's see if that maybe doesn't change what's going on in the system at the moment. So if in here, I go ahead and I test now. So in the Vox iter stuff, when we're going to do these testing, I'll just do if test entity is not equal to entity, and if there's not a flag, test entity flags and allow motion on collision, because we don't want to prevent the motion. We want to potentially trigger an event in the future, so that's the thing we might want to do. But we don't actually want to prevent the motion when we have those hits. And so now let me run this again to see whether that changed things at all. First. Okay, so people can now move, as we can see. And so now we're back to actually working on... oh, by the way, you can see why proportional derivative controllers are bad. Do you see at how low, like at low frame rates, the glove just does weird stuff? That's because there's like the weird thing we slapped on there is like underdamped, so it's just gonna go nuts, right? As it keeps moving around. So now we get more what we would expect, which is, we're moving stuff around and we're not getting into the situation where everything says that it's occupied. So as long as it doesn't have that allows motion on collision test, we will allow motion on collision flag. As long as that flag is not set, we will do a test and we'll set occupied to whether or not the rectangles intersect, right? Okay. So now, we have to figure out why we're not getting any actual stopping of motion, which is more what we would have expected to see. So when nothing moved, that was like, that was kind of weird because it's not the bug you would expect. And it turns out like, well, okay, yeah, that's because this was always triggering on like the room's boundaries and stuff like that. So we know that this code at least sort of does something, because it means that when you do have a large collider, nothing was allowed to move, but it appears that this doesn't really prevent you from moving through things for some reason. So we're not quite at the point where we're actually doing what I think we're supposed to be doing here, which is preventing motion, at least small motions, which, you know, something like the floating familiar head would be doing. So we kind of need to know, like, what is the deal here? Like, why are we not, why are we getting an entire box that is marked as movable in a way that allows you to move through things? Like, what's going on there? And looking at this, I just want to make sure that this is testing what I think it's testing. I think it is. Also, I would note that this is actually, just to clear up what's going on, this only actually gets used in here, right? So really all we're doing is we're just testing these flags, and we're saying, all right, if all of these are not occupied, so we OR them all together, which means if any of the squares are occupied, it will be a 1. And then we're knotting it. So basically all 8 corners in this lookup have to have said that they were that it was possible to move there, right? And so this looks pretty reasonable to me, so I guess I'm not sure why we're getting nothing. We'll have to step through it, but again, I'm not sure how to set up a scenario that will actually produce what we want to have happen there. So I kind of want to see, do we ever hit? It doesn't look like it really. It looks like you can just punch straight through. So it doesn't really look like it's ever actually preventing any types of motion there. So why would that be? Why would we not be seeing at least some, why would we be never seeing any change there, right? And just to make sure, I don't actually know what this rectangles intersect thing does, but I'm assuming we're already using it, so we know that it's not completely busted or something like that as well, which I suppose is the thing. But let me just verify. Looks reasonable. So, yeah. Not sure. What I would most like to do is draw this out. So I'm wondering if maybe I just will. So basically, like, a way that I can draw out a thing that shows me the voxel that was used on a particular move. And I can see, like, what the actual occupied status is. So for example, like if we go into the entity code and we've got, you know, something that push down some of this debug stuff, like push volume outline, and I put one of those in here for the voxel, for example. And the problem here is we would need to actually send down a render group to this, but I'm okay with that for now, for debugging purposes. I also don't know, like, we don't have debugging. Maybe we do. I'm assuming we don't have any drawing here. You know, we really should have. Our debug system sucks, frankly. It's one of the worst things we did on Handmade Hero. Just mostly because of focusing on the wrong things, I think. But what are you going to do? So anyway, what we would like to do here is the render group. If we pass down the render group here, and I just take a look and see like about pushing down some of these guys. So if we have a rectangle and we want to draw it, what I can do is just draw which cells it thinks are open. For now, I don't have a better idea, right? But we can just do this and say, look, go ahead and draw the cells that you think are open. And maybe for now, I'll move this back out here and we'll just draw them each time. So we would basically do like, a cell color equals, maybe green, and then set it to red or something like that if it can't be moved. So like red is can't go, green is can. And then we just do some nonsense like this, where we we do that. And I don't know what's it complaining about. Cell color is the wrong type, and not only that, but I'm so in Star Code Galaxy mode right now. I just have not been thinking in terms of floats. The brain just goes in a direction, right? So I'm going to pass the render group here for debugging, and again, we just want to pull this out later after we're done, because we don't actually want any of this stuff to be in there. But for now, we want to just do some drawing in there, and so we can see what the heck's going on, right? And so my hope is that like if we zoomed in, we could sort of see like, because I can, right? You can see it, right? You can sort of see it drawing now those green streaks, right? And so like as it moves, you can sort of see that like it's all green in there, like there's no red even when it probably should be, right? So if I for example, if I place myself, so there's actually some red right there, in fact. So it's actually got, that's weird. It actually looks like it's correctly, denying those motions, but then they're still happening. I mean, it could be because we're just not actually subdividing the step and it's able to tunnel through, but it doesn't look like it. Like the hand is appearing inside here. So it seems like maybe I must be thinking through this a little bit wrong somehow. So again, let me try switching to preventing moves in the case where nothing is found. Weird. So that actually makes the collision detector work, right? Which makes no sense to me whatsoever. Because it should always be able to find its existing point. I guess not when it gets close enough to something. Interesting. I mean, I'm not sure what we want to do about that. When we add subdivision, it may take care of itself. But I don't know. That actually works remarkably well now. And see, do you see the tunneling? If I get up enough speed on this thing, I can tunnel it through, which we're allowing right now because we never subdivide the move at all. So if the voxel can span, it will allow you to tunnel, which is by design. That's what we would like it for it to do. So that's great. I mean, I'm just testing this here, and it works really nicely, right? Because I can. So these guys, these things don't obey any collision detection, right? And so you can get the glove stuck into it pretty easily, and so that it, goes through there and it gets stuck on stuff, which is what I wanted, and it comes back out, which is the main thing that I wanted to make sure was always happening, right? So you can see now with like really large motion steps, you can tunnel through things, you can get out of things, which is what I want, right? That's what I wanted to see. So that's good, actually. But now we have to actually go and say, well, okay, but so if I subdivide to only relatively small motions, the tunneling won't happen anymore, and then we would be left with basically a correct collision detector, I think. But the only problem is that I kind of don't like the fact that we default to non-motion, so if we start subdividing, I'm wondering if we will be able to do something where we can fix that, so that we default to being allowed to move. But I'm not sure. But already very promising. I really like what I'm seeing so far. And that's because I can get this thing stuck by putting it in a place where it can't move anymore, and it always comes back out. And that's the main thing I want, is to make sure that that we're not going to get stuck, right? And so I think that's okay. But like I said, I'm nervous that if I then go to do the subdivision thing so that it can't take large steps anymore, if the default is can't move, that it might get stuck again, right? So I'm at least a little bit worried about that. It's not wouldn't be my first choice, right? So I don't know. I don't know what to do about that. Let's start adding the subdivision. I guess for now. And maybe we'll just call that good enough, but I don't know. I may want some more. I just don't know if that's sufficient. Right? I just don't know if it's sufficient. So I don't know what I want to say about that. That worries me a little. So we'll start though by just doing this desired subdivision part here. So basically we just have a t value. And all I want to do is I just want to make sure that we subdivide this into a reasonable number of steps. And so if it's too large, I want to subdivide it. I want to like basically bisect it so that large motions get bisected into smaller motions until we get down below a particular threshold. And so, something along the lines of let's suppose that we have a total length that's whatever the delta P was, right? And there's some stuff we want to do separate from this that's like reverse engineering the acceleration and the position. There's other stuff we want to, yeah. We probably want to be position based and reverse solve, but that's a separate issue for physics purposes. That it has nothing to do with collision detection. It's just what we will do at some point. Don't worry about any of that. We'll take the total length here, and what I want to do is like a max or like a step length, right? And I want to say that, look, I don't want anyone moving more than some amount, whatever that amount is. And this is probably like some fundamental constant, like, you know, physics or like motion displacement size or something like this, where we say when we're doing this, we've got some fundamental constant that's like, you know, 0.01 or something. And the apron that we use, you know, and maybe it's more like that. And so the apron that we use is like a 10th, you know, of the motion displacement size or something like that. I don't know. And then the motion displacement size is this, right? And so what we want to do is say, how many steps are we going to have? So we would say, like, you know, the step count here is going to be the total length of the thing divided by how many steps there should be. And we know that we want at least one step count. So however many there are, we know that there can't be less than one step. You know what I'm saying? All right. Fine. Just fine. Whatever. Be that way. No one cares about you. Okay, so we're going to go ahead and say produce a step count. It has to be... Are you kidding me? There. Jeez. So it has to be at least one, and it will be up to the total length divided by the motion displacement size. So if there's a longer one, like someone's trying to move an entire unit in one frame, we'll actually do 10 subdivisions. That's probably too much, so we're probably going to make this not be that large as it is right now, but, you know, that's a constant we can tweak based on what we want our largest things to be. It's sort of a separate issue, right? We don't have to care about that right now. All right. So looking in here where we get the step count, we would then just say, look, we're going to do our step index, and we're going to go through the step counts one by one. And for each one of them, we're just going to produce a new desired position and attempt to move the entity locally from its current position to wherever that is, right? And I mean, I guess we kind of just want to stop if it can't. So, I mean, I guess we kind of really actually want to just stop if it can't. So we want to do, like, you know, we may just want to do something like this. So we would take the desired position would be the entity's original position, right? So like before anybody moved it. It would be the original position plus the step index over the step count times the delta that we were trying to move, right? So that much of the thing we like add in each time. You know what I'm saying to you? So like if the step index, and it's gonna be like +1 because the step index starts at 0. So we want to start. If their step count was 1, we'd want to move it the whole way because we're only gonna try once. If the step count is 2, we want to start out at 50% and then try to go to 100%, right? So we've basically got a t on the on the step, so we can compute that like so, and then use that to move our saucy gentlemen, whoever they are. And then what we want to do is we want to let move entity locally tell us if it succeeded. If it didn't succeed, then we don't want to keep trying because there's no point in doing so. So in here, we just want to say, look, if we never hit a positive case, then just give up and stop trying because you're never going to ever get anywhere beyond that, right? Or you could, but you might tunnel, so we don't even want you to try, might be the better way to say it. So I think that's what we want there. That is missing a parentheses, I think. Is it? No, it's not. I take it back. What is the problem here? Missing, but oh yeah, well, okay. I'll give you that. I'll give you that one. So for reasons unknown, that seemed to allow those two to move onto each other, which is very strange. So that actually seems bad, what I just did. And also, the glove can't move, but the other dude can, which is very strange. Oh, I guess because it's sunk into the floor is the problem there. So this is why, you can see why I wanted that to accept the 2p value, right? He says. So I'm curious about other kinds of motion. You can see it's struggling a little bit. So you can see like this dude is properly not allowed to move, right? And if he were a cylinder, he'd glide off that edge, which is why we want that, right? So he's probably not allowed to root. You can see the subdivisions actually chugs the frame rate there, right? But the problem that we're going to have here is just that, like, okay, so at that point, the subdivision for the motion is down to a level where it really doesn't allow the glove to, like, get out of interpenetration. So I don't know what we want to do about that. That's a tough one. I'm also at least a little weirded out by how many steps that seems to have been taking. Because this really should not happen that much. In my opinion. Because people should not be moving that fast. I'm going to get rid of the push volume outline there, since that is generating a bunch of stuff. But, like, it's really kind of remarkably hitting performance. I wonder if I did something weird there, because there's not that many, like, there's a lot of chugging going on there, right? Which suggests that we're sort of subdividing this thing a lot, which doesn't make a whole lot of sense to me. Like, you see how harsh that is? Right? So that's a bit strange, and I'm wondering why there would be something trying to do that much. Like what is this step count actually getting up to? Such that we're seeing that. Now, granted, like I said, there's no spatial partition, so it's looping over all the entities for those collision detection cases, so it should be slow. But, I mean, look at that. Look, right off the bat, it hit one where it was trying to take a step of 10, right? And motion displacement size is 0.1, so that's suggesting that on one frame, right, it was trying to go a distance of 1 unit on that frame alone, which seems a little bit broken. And so I'm just curious to know, like, who is that? Like, who is doing that and why? So let me go ahead and see. Maybe I've got something stupid in the code here. Also, I think we're out of time, so I should probably stop, because we did most of what we want to do today, which was rewrite that routine to get us into a better position for doing stuff. But it's kind of a separate issue. So let's see. Like, what's the step count here? 15. Oops. So it's trying to move 1.5, which is nuts. That's just nuts. We need it's a floating guy. So we need some limits on how much these people are supposed to be moving, right? That's just really crazy. And we could artificially cap it. So we could just say, look, the step count here is is only 5. And so we'll just say, like, to do Casey, look into capping more directly. Right? because we don't really know how we want to do this. But that is way too much, and so that means someone's asking for unreasonably large moves, which makes sense because we just slap some springs on some, like, it makes sense that that kind of nonsense is happening. But let's just take that out of the equation for now. So we'll see. We'll see if that's any better. And now, but we still don't have any real plan, and so this is our thing to think about for next week. How do we want to start progressing a little bit better on this routine for how we deal with the startup and shutdown cases there? Because since right at the moment we're only doing that, still seemed too slow. Yeah, there's still way too much lagginess there. Which granted might just be because, hey, it loops over all the things. So it could just be because, hey, this doesn't have a spatial partition. We need a spatial partition, so, it could be that. But we'll see. So, all right. Let's go to a brief Q&A. Why use CPU application? The rendering is done by GPU. It's lighting, is the mainly the reason. We do the lighting on the CPU side right now. If we didn't do that, if the lighting was disabled, so like if we went into the lighting and just say you don't have to do lighting, so so in here somewhere we just said, like that, then we wouldn't have to worry about it. I hate unreachable code warnings because I want a way to just say, like, return and yes I know, like, I know it's yes, like we all know it, like, thank you so much for your help. But they can't do that or whatever. So here. So if you nerfed the lighting, and so you were just doing this, right? Then if we switched this to debug mode, you wouldn't probably have a whole lot of need for it. But, I don't know. We'll see. So, or not. So it looks like we still are pretty slow. I'm not sure where that's coming from. We could run the profiler and see. So what's the actual slow part? It could be also in our debug, our super crappy debug system, which I suppose is also an issue. But let's take a look at who that is. So here we are. So update and render entities is the other big frame time. And I guess we don't really know. It could even be the thing that we just wrote that is the problem there, but who knows? So if we took out some of that stuff, we could maybe start to see, like, maybe I can go in there into move entity and say, like, is the stuff we're working on now, which is crappy, is that something we could, that is a problem? Timed function. Isn't that supposed to just work? What is the problem with timed function? All right. I don't know, yeah, to what extent move entity is now a problem, because we're doing all this voxel stuff in there, but we can take a look. Yeah, so it's what we're doing now is part of the problem, although update and render entities is also kind of slow. So all the crap that's going on in there is not great. So like if you imagined you nerfed this out, so you just said like entity p plus equals delta p, and this went away. So you don't have that loop over all the entities anymore. Then you run in debug mode, and now we're down to just the update and render entities call, I think. Compute light propagation work, I have to turn off. And so now, like, our update and render entities call is still kind of crappy, right? Because you can see, like, here's us not calling that, and we're running along at 60 frames a second, right? And then as soon as we actually start in the game, though, it drops down quite a bit. So you can see here, like, you know, this is totally playable, though. You could play at this frame rate and be fine. So actually, yeah, like it's mostly just the lighting and the collision now. The collision will get much faster as we work on it, so that we could probably just do fine. But the lighting, there's nothing, like the lighting is what it is. So that, as long as the lighting stays CPU side, we need optimization there, and there's not much we can really do about that, right? That's just how it is. So yeah. Doesn't the orig p need to be updated each step? No. I don't think so. So if you look at how this loop is working, it basically says, look, I'm going to go from where I was, and I'm going to move the percentage of the requested delta that is the step I'm on, right? So it's always starting at the start point and moving some percentage of the delta, going from 0%, well, going from some fractional percent to 100% over the course of this loop, right? And I did it that way on purpose. I didn't want to keep adding small vectors together, because if you do that, you may end up, again, in numerical precision land where it doesn't actually work correctly. So